Let's go ahead and get started. So MACsec, so this is a new feature that we're introducing with the CX product line. So the 32 port 8360 has 4 MACsec ports that can operate at both 10 gig or 25 gig. And so let's go ahead and talk about MACsec. So MACsec, for those not familiar with it, it's a layer 2 encryption mechanism. It's a hop-by-hop encryption mechanism over point-to-point Ethernet links. Of course, MACsec was really designed for local area networks, LANs, right? Because wireless networks use different protocols for this type of encryption. But MACsec helps us encrypt the LAN portion of the network, and it really helps enable, a secure link, a bidirectional secure link, after the two ends of that link do exchange security keys. And these security keys come in the form of a static connectivity association key, and they're leveraged using the MACsec key agreement protocol. Of course, these types of MACsec encryption solutions help protect networks from a wide range of attacks, including denial of service intrusion, man-in-the-middle and eavesdropping attacks. Those types of attacks that really exploit layer 2 type vulnerabilities. You can see on the right, MACsec enables connectionless data integrity. So, any sort of unauthorized changes to a frame cannot be made. Data origin authenticity is ensured with MACsec. Confidentiality, because we're encrypting the frame with MACsec. We have some replay protection mechanisms that help us accept packets out of order, but it also helps us from not injecting those packets back into the network like they're attacks into the network. When we're looking at MACsec, it really adds, the frame format adds an additional 32-byte MACsec header, and it uses the well-known ether type field 88E5. But it allows, of course, the Ethernet source and destination MAC addresses to be left in the clear. So, of course, the devices can forward the traffic. Of course, as traffic goes across these encrypted links, the receiving device is going to check that header and that tail. And of course, if the check fails, traffic is dropped. If the check is successful, then the frame is decrypted and then passed on. Now, MACsec actually encrypts all of the fields behind the source and destination MAC address, unless you configure an offset. So there's confidentiality offsets that allow us to set that point at which encryption starts off by a few bits to be able to expose certain tags in the frame. I mentioned it uses the MACsec, it leverages the MACsec key agreement protocol, and it's going to use a connectivity association key. And these are presented to us at the CLI in a form of a pre-shared key. And that pre-shared key is going to have both a connectivity association name, or a CKN, and it's going to have a connectivity association key. And those are the really critical features that components that need to be configured the same on both ends of a link. We need to make sure that this pre-shared key matches when we're on both ends of the link. Otherwise, it's never going to come up. The other important thing to note is the CX switches actually support a range of Cipher-Suites. So we support 128 as well as 256 and the XPN range of Cipher-Suites. And that's another thing when we're configuring MACsec and trying to get it to work in the real world, is we need to make sure that the Cipher-Suite that the protocol is trying to configure matches on both sides of that link. Now, the CX devices are going to automatically try to use the strongest Cipher-Suite possible. So we need to ensure that the other link also supports that same type of Cipher-Suite. And the CX devices, by default, their key server priority is automatically set to 0. So that should mean, because the lower key server priority means that that device is going to become the key server. That should mean that the CX devices becomes the key server. But that's another thing we want to check when we're trying to configure these, is which device is the key server. When we're looking at the, like the handshake for a couple devices configuring a MACsec link, the devices are actually going to exchange this pre-shared key that you'll see in the configurations using EAP packets. And they're going to exchange these parameters using these EAP packets. And of course, the parameters are going to include things like that key server priority, whether the device actually does want to encrypt traffic, and of course, the pre-shared key. that type, that there's a typo here, sorry. The port with the lower key server priority becomes the key server, and it's going to generate that secure authentication key. Once both devices have this secure authentication key, the link will be up and the MACsec secure tunnel will be secured. With regards to use cases, so with CX devices, we support device-to-device MACsec. So when we're thinking about use cases for our CX solutions, you know, there's a number, especially within our campus types environments. So like, let's say we have an environment where it's multi-floor building. We can use these types of solutions to help secure that traffic as it goes between the different floors. So we can secure the fiber in the risers of the building. Similarly, on a distributed campus that maybe has multiple buildings across a campus, we can also do the same type of thing when we're providing links between these buildings. We can help secure these site-to-site links between these buildings. And very similar to that, of course, would be like a data center interconnect using dark fiber between a couple data centers. And also, not surprisingly, something like an ERPS ring. So now we're going to jump into the configuration and the fun part. So I'm going to actually turn it over to Abhay from engineering.
Hey, hi, thanks, Steve. So hello, everyone. Steve, I think it would be great if you can just continue presenting. I don't have the slide decks with me.
Got it. Okay.
Yeah. So the first thing you would want to do is create a MACsec policy. So on CX, unlike AOS switches, we have two different policies that you would want to configure to have MACsec up and running. There is the MACsec policy, and then there is an MKA policy, which we'll get to later. So you would start by creating a MACsec policy, policy name. You can have a string up to 32 characters long as a MACsec policy. So you can, so we'll get to the syntax about associations later, but yeah, a MACsec policy can be associated with a physical interface or a lag as well, right? So you can actually associate a MACsec policy to a physical interface, and if you want choose to do it on a lag, you can do that as well. And the no form of the command obviously deletes the MACsec policy. One caveat being that if you have a MACsec policy already attached to an interface, you cannot delete it as long as you have it attached to one or more interfaces. So you have to first disassociate that before you actually go ahead and delete the MACsec policy. Yeah, next slide. Yeah. So once you have the MACsec policy configured, you would want to tune certain parameters in the policy itself, right? The attributes. So the first one being confidentiality, right? You can turn on or turn off the confidentiality setting in a MACsec policy. So when you have confidentiality enabled, which is the default setting, packets over the MACsec tunnel are encrypted. So after the source and destination MAC addresses, the packet is encrypted starting from the ether type, right? So if someone actually taps the link, they can't see anything beyond the MACsec header itself. You can turn it off, right? If you do a disable confidentiality, you can actually see the entire packet in plain text, but it's still MACsec protected. You still have the MACsec header, so you still get data integrity kind of protections, wherein if someone actually snoops and re-injects packets, you can still detect it, but the content in the packet, the payload in the packet is still visible clearly. So as Steve mentioned before, you can still instead of turning off confidentiality, you can still choose to have confidentiality enabled, but with you can choose to have certain bits of the packet sent in plain text, the first few bits of the packet, using the confidentiality offset setting. So there are 3 offset values that you can set. The default offset is obviously 0. So when you have confidentiality enabled, the offset value is automatically set to 0. So you can override it to an offset of 30 or 50 based on your requirements. Yeah, that's about it. Yeah, next slide, please. So once you have the confidentiality setting checked out, right, next that we talk about is the secure channel identifier. So within the MACsec header, I think in one of the previous slides that Steve presented, there is a secure channel identifier tag that is embedded within the MACsec header. So this is nothing but a combination of the MAC address of the interface and the logical port identifier that helps if you have multiple MACsec endpoints on the same link, you can use this SCI to actually differentiate which endpoint is actually trying to communicate with you. So if you are having more than one MACsec channel on the same link running, which we currently don't support on CX, but when you do have it, you would want this SCI actually enables the FI to identify which channel the MACsec is the packet is coming over. So you can, by default, SCI is enabled on CX. So you can choose to disable it using no include SCI tag. So for a point-to-point link, technically SCI isn't mandatory. But if you have more than one MACsec channel running on a single interface, you would want to keep it enabled. And yeah, another caveat being you can't have an asymmetric configuration for include SCI tags. That is, you can't have include SCI enabled on one side but disabled on the other. That is something that isn't supported. It's not an RFC mandated thing. It's just a FI capability that the FIs that we use on the 8360 don't support this configuration. So this is something that you want to keep an eye out on. Yeah, so coming next, coming to the replay protection part. So replay protection is a mechanism wherein you can actually tell the switch if you want to accept out of order packets. So if you have another underlay over which these MACsec packets are actually, so though it's point to point, you can have multiple hops, a layer 1 hops between two MACsec endpoints that actually carry the packet. So if you want to actually allow out of order packets to turn up on the other side of a MACsec tunnel, you would want to turn off replay protection or turn on replay protection with the window size. So window size determines how many packets you are what offset how many packets are allowed to be out of order, right? So by default, replay protection is enabled with a window size of 0. So that is, frames are expected to come in a strict order. So if you expect packets to come out of order in your topology, you may want to set the window size accordingly or turn off replay protection, though it's probably not the best idea to do so. So you can choose tune your window size based on your topology. So the next part is configuring the Cipher-Suite, right? So as Steve mentioned, unlike AOS switches where we only supported the AES 128-bit encryption, we support all the RFC mandated or the currently popular Cipher-Suites, right? The AES 128, AES 256, and the extended packet number versions of both. So we support all 4 Cipher-Suites on the 8360 today. So by default, we have all these Cipher-Suites enabled, and if the 8360 acts as the key server, we would end up choosing XPN 256 as the Cipher-Suite for the channel. So if your other end doesn't support it, you wouldn't see the MACsec session coming up. So you need to be careful on what your Cipher-Suite configuration on the MACsec policy is going to be. If the other end of your MACsec channel is going to be a 5400R or a 3810, you would want to keep the Cipher-Suite configured as AES 128 because if 8360 acts as the key server, it would choose the XPN 256 variant, which would mean that you won't have the MK negotiated successfully. But yeah, we support all 4 versions of the Cipher-Suite. Yeah, so like I mentioned, we have 2 different policies that you would need to configure to have MACsec up and running on CX, right? So we talked about the MACsec policy. Now we are going to talk about the MKA policy. So in AOS switches, we only had everything dumped under the MACsec policy context. But in CX, we chose to have 2 different or kind of separated logically, right? The MACsec configurations which are defined in the .1 AE standard and then the MKA policy which are actually defined in the .1X standard. So the MKA policy is obviously similar to a MACsec policy in terms of how you configure it. You just say MKA policy and then the policy name, it could be a policy name with up to 32 characters. And you would want to delete, if you want to delete it, you just use the no form of it. And again, like MACsec policies, you can associate it with a physical interface or a lag. Yeah, so once you have the MACsec policy created, the most important aspect of the MKA policy is to create the pre-shared key. Like Steve mentioned, this is the configuration that dictates what's the CKN and CAC going to be, and to have a successful MACsec channel established between two endpoints, you should make sure that the CKN and CAC are identical on both ends of a MACsec channel. So a CKN and CAC are hexadecimal strings, right? So you can use them, and you can actually configure those together. And when you configure the CAC, there are three ways you can do it. You can just say plain text and give the whole CAC. You can do a plain text and then click enter, and you get prompted with enter password, or then you can use the ciphertext option as well. So once you have the CKN and CAC configured, you would want to tune your key server priority. By default on CX switches, as Steve mentioned, the key server priority is set to 0. A lower key server priority means higher likelihood of the switch being the key server. So since its key server priority on the CX switches are 0, it's highly unlikely that the CX switches are going to be chosen the key server. In case of a tie, the .1x standard mandates that the one with the higher SCI actually gets chosen as the key server priority. So if you have two MACsec session between two 8360s with the default key server priority, the one with the higher SCI gets elected as the key server. So you can actually tune your parameters accordingly to make key server priority, to make sure that who you want to be the key server, right? This is one thing that you can use to determine, guarantee which of the MACsec endpoints is going to be the key server. So it's an integer that can range from 0 to 255. So once you have the key server priority configured, the last item would be the transmit interval. So this is so MKA packets are transported over EA-POL, and you can define the interval at which these MKA packets are exchanged. The default value as defined by the standard is 2 seconds, and that's the default that we have on CX as well. If you want, you can actually change it to a value higher than 2, between 2 and 6 seconds. But we would highly not recommend anyone to do that. So it's a configuration that's available if you want, if the topology warrants that the transmit interval be greater than 2. But if as defined by the standard, if the MKA packets are not exchanged within a window of 6 seconds, right, the MACsec channel is actually destroyed. So if you keep a value of 6 seconds as the transmit interval, if you don't get a single packet in that 6 seconds, you are anyways going to lose the MACsec channel. So it's not recommended that we change this value, but it's available. Yeah, so once you have the MACsec and the MKA policies configured, the next step obviously would be to associate it to a port. This port could be a physical port that's not part of a lag that supports obviously MACsec, or it could be a logical interface as well, a link, a lag. So once you associate a MACsec policy to a port, all the data traffic is blocked on that port until a successful MACsec channel is successfully established. And for MACsec to operate successfully on a port, you need to have both MACsec and MKA policies associated with it, right? If you miss one of them, you wouldn't see MACsec channel being established on the link. So you want to keep an eye out on that. So when you actually have a MACsec policy associated with a lag, and let's say you have an interface in the lag that doesn't support MACsec, that interface would be kept down. And though the user is warned before such a configuration is actually being applied, let's say the user chooses to override it, the interface would be kept down, and until you actually remove it from the lag or remove the MACsec policy from the lag. And if you try to apply a MACsec policy on an interface that doesn't support MACsec on the CLI, we would error out. We wouldn't allow such a configuration. And if via REST such a configuration is applied, the port would be kept down. And on the 8360, the SKU that we currently have, only interfaces 1 to 4 support MACsec. So you can't actually have MACsec configured on any other port. And on the JL700A, right, we don't support MACsec and PFC together. So you can't have them enabled on the same interface at the same point. When you actually try to configure that you would see a prompt on the CLI warning the user. So if a configuration like that is still applied, that is both MACsec and PFC are configured on the same interface, the interface would be disabled until one of them is actually unconfigured on the interface. Obviously, you can only configure a single MACsec policy on a port. Yeah. So then you have the MKA policy. As I said, you would also want to apply an MKA policy on a port. Similar to MACsec policy, you can apply it on a physical interface that's not part of a lag or a lag port itself. And similar to MACsec policy, again, if at all you try to apply an MKA policy on a port that doesn't support MACsec, you will be prompted with an error message. And if it, in case of a lag, the lag, the interface on the lag that doesn't support MACsec will be blocked if the lag itself has an MKA policy associated with it. Yeah, so those were the configuration commands. So once you have MACsec policy and MKA policy configured on an interface, you would want to verify if everything is fine. So we have the show MACsec policy that allow, just displays the MACsec policy is configured on the system. You can use obviously a policy name to just dump the specific policy. And then the show MACsec status command. The show MACsec status command shows at a, as a brief summary of what are the MACsec sessions that are actually running on the switch, right? You can filter them based on the interfaces you want to. So it actually shows up the interface name, the port ID. So which is the logical port ID that is that we talked about when you have an SCI. The SCI is made up of the interface MAC and the logical port ID. For a point-to-point leak, all the port IDs are going to be 1. So if we ever support MACsec on a with virtual ports, that is, if you have multiple clients connected over the same interface, if you want to have a separate MACsec channel between each of those endpoints, you would see different port IDs at that point. But for 10.6, we only support point-to-point MACsec sessions. So the port ID is anyways going to be 1. You would see the policy that's actually applied on the interface and the current protection level, right? IC indicates integrity check is enabled on the link. Conf indicates that confidentiality is enabled on the link and what's the offset value associated with it. So if you only see IC as protection, that indicates that you have confidentiality turned off on the link, and status indicates what's the current control port status. Actually, there is another version of this command. This is a little older. I think when the next slide probably talks about the latest. We also have a summary that says whether the MACsec channel itself is up or down. So we'll get that updated.
Yeah, this one has
this actually, clarify. Yeah, exactly. So this actually talks about what each of those, parameters or these columns mean in the output, right? So the state indicates what's the state, right? That's the control port state as defined in the .1x standard. So you would want to see the state as retire if the channel is up and running correctly, right? You would see it as retire. A state of init probably indicates that the MK is not secured between the two endpoints and something is wrong. You would want to just check that. So it should transition from init to secure to receive to receiving all the way up to retire, for you to actually see that the sessions are actually up and running. And for the sake of, if people are not tech savvy and they don't care about exact the CP states, we have a simple status that tells whether the channel is secured or not using the up and down values. So a status of up indicates that the MACsec channel is up and it's running fine. Yeah, so this is actually the current state of the output. So it indicates whether the status is up or not and the CP state. So you would want to check that the state is up. So that we also support a lot of statistics related to MACsec. There are RX and both RX and TX statistics, and then there are the SecWise statistics. So the whole bunch of statistics, I wouldn't get into each of them, but you have a lot of statistics available to probably debug issues or verify if the channel is up and running and what sort of packets are actually being transmitted over the link. And you have a clear MACsec statistics command. So you can actually clear the statistics on one or more MACsec capable ports. So when you actually run this command, unlike a lot of other commands, we actually clear them in the database, which means that it's wiped out across the system and not only on that session, which I think was not a very popular choice among a lot of support folks, where we only clear the statistics on that particular user session. So in case of MACsec, we go ahead and clear the MACsec statistics in the hardware and on the system. So even on another parallel user session, if you check the statistics after you clear it, you would see it as 0 and not see the previous statistics. Yeah, the next commands are related to MKA. So similar to MACsec policy, you can verify the MKA policy details using the show MKA policy command. You can optionally give a policy name to only dump the policy details with respect to a specific MKA policy. So it shows whatever you have configured on related to the MKA policy. And then you would want to see the show MKA status, right? So before you actually have a successful MACsec channel established, the MKA state session should actually be secured. So if you see the output of this command, you would see a MKA session status that shows up as unsecured or secured. So this is MKA is actually first secured before the secure association keys are exchanged between two MACsec endpoints, which actually get the MACsec session to be up. So this actually lists what are your peers and whether they are in the potential or live peer list, right? You would see a peer in the live peer list once you have an MKA session secured. So, but that is both of them have the same CCAN and CAC configured. We also have a lot of statistics, that are actually specific to MKA that we support. So you can see what are the number of packets, the MKA packets being sent or received, and how many SACs were actually distributed if it's acting as a key server, and the number of SACs received if it's not the key server. If there are any invalid MKA packets received on the channel, you would even see those in the statistics. Yeah, similar to MACsec policy, you can also clear statistics associated with the MKA policy. So it's just clear MKA. There's a typo which we can fix it. So it's clear MKA statistics, and we actually clear statistics again across the system and not only in that user session. One more point is that MKA statistics are actually polled every 5 seconds. So they get updated every 5 seconds. That is something that though the MACsec statistics are updated on user demand, right? So whenever a user executes that command, the latest statistics are published. For MKA statistics, we publish it every 5 seconds. So we refresh it every 5 seconds. So that is something that you would want to keep an eye out on. Yeah, coming to best practices, we have a bunch of suggestions on how to configure MACsec. So when do you want to use MACsec? You would want to enable MACsec when you have the link. There is a potential of that the link can be compromised. That is like if you have a dark fiber running between two stations, and you have a chance that the link can be compromised, you may want to turn on MACsec on that. So one drawback with MACsec is MACsec adds a 32-byte header to every packet that's actually transmitted on the data plane, which means your link capacity comes down by a factor of 30%. Depending upon what the packet size is, you could actually not get the complete bandwidth on the link for data frames. So if you are already having a link that is close to the link capacity, turning on MACsec could mean that you would start seeing drops. That if you want to avoid it, you have to either have MACsec turned off, or you may want to see how you increase the link capacity itself. And we always recommend to use the default values for MACsec and MKA policies. That is, have the confidentiality turned on. There is no having confidentiality turned on or turned off doesn't have any performance issues. So it's not like you are going to get better performance if the packets are transmitted in plain text. So you get the same performance with confidentiality enabled or disabled. And confidentiality offset of 0 probably works for most cases unless you have some sort of load balancer or anything which probably needs to look at the packet, right? You would want to then use a confidentiality of 30 or 50 to look up the first 30 or 50 bytes, let's say the IP header or something, to make some decisions and then transmit the packet accordingly. Replay protection enabled with the window size is again recommended. You would want to keep it turned on unless you expect packets to come out of order, in which case you may want to still keep replay protection turned on, but with a non-zero window size. Yeah, Cipher-Suite. Please make sure that the Cipher-Suites that are configured on both ends of a MACsec channel are the same, right? If you have it misconfigured, you would see the MACsec session not getting established at all. So please make note of that, and especially when you have a different vendor on the other side, right, or an AOS box, you may want to make sure that what Cipher-Suites that the other end supports and configure the MACsec policy accordingly on the on this 8360. Use the key server priority to make sure that whichever device you want to elect, you want to be the key server, please make sure that it has the lowest key server priority. And you can have the include SCI disabled. That will give you a slight improvement in performance, because 8 bytes of data is not actually, the MACsec header actually shrinks by 8 bytes. So you probably get a bit more of your link capacity back, because since it's only point-to-point links, having the SCI tag in the MACsec header probably is not going to help much. Yeah, so another point to note is if you make any changes to a MACsec policy while there are active sessions running with that specific MACsec or MKA policy, the user would be prompted with a warning message that the channels are going to be destroyed and re-established, right? So we delete the MACsec sessions and re-establish them with the latest parameters. So if you are going to make a change to an MACsec or MKA policy, please make note that the channels are going to get destroyed and re-established, which means you are going to see drops for a good 8 to 10 seconds while the MK is again negotiated and the MACsec channels are established back. Coming to interop, the R&D has tested with Cisco, Comware, and also with our own AOS products, right? So with Cisco, there are a few caveats that we have come across. That is, Cisco devices need to be the key server. With CX as the key server, we have seen some problems where the MACsec channel doesn't come up, right? So if you have a topology where the other end of a MACsec channel is going to be a Cisco device, you may want to configure the key server priorities accordingly to make sure that the Cisco device is selected as the key server, right? And we have verified this with CAT 9300. With again, Cisco, the 9300 supports all 4 Cipher-Suites that the 8360 supports as well. So based on your requirement, you may want to choose the most secure Cipher-Suite to guarantee maximum protection. The Comware device that we have tested with is the 5940. We advise the confidentiality offset to be 0. We have seen issues when the confidentiality offset is 30 or 50. So it's advised that you use a confidentiality offset of 0. And I think the Comware devices only support AES 128, so you may want to configure the Cipher-Suite accordingly as well. With AOSS, we only again support 128-bit encryption there, so you should take care of the Cipher-Suite configuration there. And the confidentiality offset again is only a confidentiality offset of 0 is supported on AOSS devices, so you can't have an asymmetric configuration there. And this has been verified with the 5400R and the 3810. Yeah, coming to troubleshooting, we have a MACsec as a feature under the copy support files and diag dump commands that you may all be familiar with. So if you want to capture some diagnostic data related to MACsec, you may want to use that. So if there are customer issues that you want to report, we recommend you to use the copy support files all to make sure that we capture everything on the system and not rely on just the MACsec part of it. So you also support debug logs for MACsec, so you can do a debug MACsec call for very verbose logs which might help debug issues related to MACsec on the system. So typically, when do MACsec sessions not work between two endpoints, right? So what do you want to check? Verify if the MKA session is secured, as I stated earlier. So until the MKA session is secured, right, your MACsec channels won't come up. So if they are not actually secured, why would that be? So if it's flipping between secured and unsecured, then there is probably a mismatch in the confidentiality setting or the Cipher-Suite setting, right? The Cipher-Suite advertised by the key server may not be supported on the peer, or the offset configuration is something that is mismatched between the peers. So in those cases, you would see the MK session going from secure to unsecured, again and again, right? And then when verify the MACsec. So once you have the MK session is as secure, verify the MACsec status is up and the state shows as retire. So, and when you have the MACsec statistics, you have MACsec statistics available to check if there are packet drops, use the statistics command to capture, statistics and verify if everything is okay. There is an okay packets field. You can verify that on the RX side, if they are incrementing. If you see the not valid packets increment, that indicates that there is probably a mismatch in the SACs programmed on either side of the MACsec channel. So because of which the packets are actually getting dropped. Yeah, coming to resources, finally, like I talked about, MACsec has two standards. The MACsec standard itself, which is described in the .1 AE standard, and then the MK piece of it, which is described in the .1X standard. So there we have some, quick references to the Cisco and Comware configuration guides for MACsec, and also the Aruba 3810 access security guide that talks about MACsec configuration.
Great. Thank you, Abhay. That was great information. I'm going to actually jump into a demo for you guys. This is the environment that we have set up in our lab here. So we've got a couple 8360s. They're hooked up back to back on port 3. And then we've also got them hooked up to a Comware, whoops, it's a 5940, sorry. Comware 5940 and a AOS switch 3810. And of course, what we want is in that show MACsec status command, when we do that, we want to really ensure that the status says up, and of course the state, which is the state of the controlled port, like Abhay said, states as retire. So this is a great output. So let's go ahead and log into the lab and see what it looks like. Everything's gone to sleep here. So on the top, I have the two 8360s. On the bottom left is the AOS, bottom right is the Comware. Let's go to one of the 8360s. We'll show MACsec status. And I can see on all of these ports, or two of these ports, I've got an up and a retire, which is great. But on one of my ports, it's down and it's in the init state. One of the things that I had mentioned was when it's in the init state, you want to check the MKA status of it. But let's go ahead and check the other switch too. Now on the other switch, we're actually getting a status of up and a status of retire. So everything looks good on the other switch for all three links. It's just this one link over here on this one switch. So what's going on here? So actually, before we do, let's take a look at MACsec policy. With this command, I can quickly see the various MACsec policies and the configurations that they're set up for. So I've got MACsec P1, and you can see MACsec policy P1 here. It's been configured for Cipher-Suite 128, and that's because the devices that I'm connecting to, Comware and AOS switch, they only support the Cipher-Suite 128. So we had to manually do that. We include the side tag by default, of course, to improve performance on these networks. Like I had mentioned, we could turn that off. I do have confidentiality turned on here, and I have it set to 30, and I just have replay protection turned on, set to 100. There's no real reason for that. That's just playing around with the configs. Also, we've got the show MKA status, MKA policy. Let's take a look at our MKA policy. So here I've actually got a couple MKA policies. I've got MKA1, which is using a set pre-shared key. Remember that pre-shared key needs to match on both ends. It's going to contain the CKN, and it's going to contain that CAK, which of course needs to map. Now also it'll contain the key server priority and the transmit interval. And you can see on MKA1, it's got a key server priority of 0, which is the default for CX. And then on MKA2, we've got a priority of 24. Let's take a look at status of MKA, if I can type. And I'll see on port 1 here on the left, the port here is actually acting as the key server. Port 2, the port is actually trying to act as the key server. And port 3, the port is acting as the key server. Now, that device connected to port 2 is actually an AOS switch. It's not a Cisco switch, but it is an AOS switch running old code. And that old code on that AOS switch actually has a bug in it. I haven't upgraded the code on this. And that bug basically makes it act like a Cisco switch, in which we really need to ensure that that AOS switch is the key server. In this view here, we can see that with port 112, this device here, the 8360, is trying to be the key server. And so the link's not coming up. I can go to the other 8360 where all of the links are working just fine. And I can go to port 1 and I can tell that this switch is not acting as the key server, so the attached switch is. And on port 2, this switch is not trying to act as the key server on this port. So the AOS switch is actually acting as the key server. So that's why this interface is up on this switch and it's not up on this switch. So what do? We can simply go into the port 112 and we can apply the other key server, MKA policy, that has the key server set to a higher value than the attached PVOS switch. And of course, you'd want to do that on both ends of the link to ensure that you have a stable link on both sides of that. Now, of course, if I do MACsec, show MACsec status, we're going to see that all 3 of our links are up and just fine.